Welcome class to the video for Unit 2A, where we'll go over the handout and explain the topics for this section. First, we're going to talk about what are units. Okay, so 1030, Unit 2A. Understand, solve, explain. Okay, so as we said, units, what are they? Technically, what are they? Well, units are words that describe what a quantity measures or counts. So with a number that doesn't have any unit with it, like say 5, we do not know what 5 is. 5 could be 5 feet, 5 years, 5 centimeters, we don't know. So units will need to be put onto the number 5, so it's not as abstract, and it could be more concrete of something that you measure or count. So in this section, under part 2, we have a 3-step sequence to solve the problems that we're going to study. This is called understand, solve, and explain. Okay, so the first step is understand. Okay, in order to solve a problem, you need to understand what it's asking for. You need to look at what things you need to do to get a solution planned. Looking at important information, you can make a drawing, you can map out a plan, any of those things to help understand the problem. So understanding becomes with thinking carefully, and then like you can make a plan or a drawing. To know where to find the solution. Okay. The next step is to solve. So you want to solve the problem next by carrying out your required steps and calculations. Then the explain step is you want to explain what the answer is in a sentence. You can check to see if it's reasonable, those types of things. So explain is to answer the problem in a complete sentence. And check to see if it's reasonable. So in part D here, so it's A, B, C, and D, we're going to use an example of understand, solve, explain framework for a sample problem. So this is our Earth rotation problem. How fast does the Earth rotate? Okay, so in the useful some useful information will be that there's a point on the Earth, on the equator, that travels 25,000 miles in 24 hours. So what we want to do is we want to understand first. Understanding the problem is saying what you're looking for. So we are finding the speed at which the Earth rotates. Okay. And we have some things to help us. The point on the equator is will travel 25,000 miles. In 24 hours. Okay. So what we're going to do now is that we understand what we're going to do. We're going to solve it, carry out the steps. And so we know that the speed is 25,000 miles for 24 hours, per 24 hours. And we're going to divide that, and when we divide 25,000 by 24 on our calculator, we get approximately equal to 1,041.67 miles per hour. We're going to explain our answer, check to see if it's reasonable. So it's just, since 25,000 is just over 24 hours, we'll have just about 1,000 miles an hour, and we write our answer in a sentence. The point on the equator travels at a speed of 1,041.67 miles per hour. Okay, we're going to start with number 3 on this video, using keywords. So there's several words that you can use to look for, and that you can look for as you solve problems. First word is of. Okay, so what does of mean when you are working in a word problem? It means to multiply. Okay, another thing that the book discusses briefly is the hyphen. Also means to multiply, but mostly of. Okay, so that's part A. What does it mean per? What does per mean in a real life situation? It indicates division. So you want to divide. C. What does squaring mean? Squaring means to multiply something or a number or a quantity by itself twice. Okay, so there's two things there in the squaring. Then the other one is called cubing. Means to multiply the quantity by itself 3 times. Let's move on to an example where we use some of the words here. Part E is our apple example. Okay, in this apple example, we're going to find out how much will you pay for 2.5 pounds of apples at a price of $1.25 per pound. Okay, so the keyword that we're going to use in this one is $1.25 per pound, which means to divide. Okay, so we have 2, and we want to use the understand, solve, explain framework as well. So we're going to understand. We want to find the cost of 2.5 pounds of apples if 1 pound is $1.25. Okay, so solving it. In this case, since we have 2.5 pounds and we have something per pound, so we multiply. The number of groups is 2.5. And the number in each group is $1.25 per pound. So those pounds will cancel at diagonals, they'll simplify. And when we multiply 2.5 times 1.25 on our calculators, we'll get 3.125. But since money is down to just hundredths or cents, we round that to $3.13. So in our explain step, we see if it's reasonable. Okay, so we have about twice as much and a little bit. So twice as much of $1.25 and a little bit is 3.13, so that makes reasonable. And we want to say this answer in a sentence. So 2.5 pounds of apples costs $3.13. Okay, now we're going to continue with number 4. It says number 4, area and volume calculations. Okay, so in this problem, in this section, we're going to just calculate with our units, areas, and volumes of 2D and 3D figures. So part A says, how do you find the volume, or how do you find the area of a rectangle or a square? Well, simply multiply the length and the width. Okay, so you have a sample rectangle here, length and width. Okay, each of them are divided up into boxes. Okay, so if I count the boxes on one dimension, 1, 2, 3, 4, 5, 6, 7, and the boxes on the other dimension, 4, I have 7 times 4. Or 7 units times 4 units, which is equal to 28 units squared, okay, because there's 28 squares in there. So multiply length times width. Okay, part B is, how do you find the volume of a rectangular solid or box? Okay, so we have a box that we're going to draw. So it's a generic box. And in this generic box, we have a length and a width and a height. Okay, so those are the dimensions there. We want to multiply them together, okay, to find the volume. Part C. Okay, so now that we've done that before, the example here. Warehouse example. A warehouse has a rectangular floor that measures 20 feet by 16 feet and has a flat 8-foot ceiling. Okay, so we're going to go ahead and draw this out. So I'm going to draw the inside a little bit because it's going to be a warehouse. Okay, and so the floor is this part right here. And the floor says that it is 24 feet by 16 feet. Okay, so we want to find the area of the floor. To find the area of the floor, we just multiply our numbers together. 4 feet times 16 feet. When we multiply these together, we can multiply the numbers themselves and the units. Okay, so 24 times 16 and then we can multiply the feet times the feet. Okay, so they work a little the units work a little bit like variables. So we multiply the 24 by 16, we get 384 feet times feet still, and which is equal to 384 feet squared. Okay. And the next part of the problem says, what is the area of the floor, and then how much air does the room hold? Okay. So the amount of air is what we're going to calculate next. Which is equal to the length of the floor, the width of the floor, and also the height. Now the height of the building is 8 feet. Okay, so we're going to do 24 feet times 16 feet times 8 feet. Okay, now that's the same as 24 times 16 times 8 times feet times feet times feet. Okay, 3 times. When we multiply the numbers together, we get 3,072, and then we add our feet times feet times feet, and which is the same as 3,072 feet cubed. Okay, that's how much air is in there. Moving on with number 5, we have identifying units. Okay. In this one, we're going to identify the following units mathematically and in words. The price per mile of an airline ticket, found by dividing the distance traveled in miles by the price of the airline tickets. Okay, so we're going to take our price per mile, and we're going to write it both mathematically and with words. So the mathematical writing, where we use our conversion factors and so on, is in dollars per mile. That's what we're looking for, essentially. And in words is dollars per mile. So in number 6, we use the units to help us solve problems. Okay, so in our example, we have a gold example to look at. It says that how much would you pay for 2.5 ounces of gold at a price of $1,200 per ounce? So you have your quantities 2.5 and 1,200, but how are they going to relate and to get you what you want? And so we use the units to guide us. We're taking 2.5 ounces of gold, and we're going to multiply it by $1,200 per ounce. So we need to arrange the $1,200 and the ounce in a way, because it can be either way, whichever one, the numerator or denominator, so that the units cancel. And if I want to cancel the diagonals, then we have to do the dollars in the numerator divided by 1 ounce. Okay, and the ounces in the denominator, because they will cancel at diagonals here. And I end up with dollars, which is what I wanted to do. Okay, so we cancel those at diagonals, and we get, when I do 2.5 times 1,200 in my calculator, I get $2,000. Number 7 are unit conversion. And so what we're going to do is we're going to convert just some units in time and distance. Okay, so they're linear units. We have the first one is with time. We're going to convert 35 minutes to seconds, okay? So we want to use the conversion factor of 60 seconds for 1 minute to help us with converting the minutes to seconds in this problem. And so we go with 60 seconds here in the numerator for every 1 minute in the denominator. Notice that I put the minutes in the denominator, so the units will drive the mathematics because minutes will cancel and I'll end up with seconds, which is what I want. Okay, and so 35 times 60 gives me 2100. And then the units that are left are the seconds, which is what I wanted. That's part A. Another practice on unit conversions. So we're going to convert 45,789 inches into miles, okay, with the given conversion factors. 1 mile is 1760 yards, 1 yard is 3 feet, and 1 foot is 12 inches. Okay, so we first write down our number, 47,500. Back there, 500, 789. So 45,789 inches. Okay, I'm going to multiply that by the first conversion factor, and I'm going to use inches to feet, and then feet to yards, and yards to miles. That's my plan. And what's great about these conversion factors is that you can chain them together, then you can just know which ones to multiply and divide. So I'm going to first go from inches to feet. Okay, so 1 foot for every 12 inches. Now I did the conversion factor this way. I could have done it 12 inches per foot, but I want my units to cancel at diagonals like you can do with fraction multiplication. Next, we're going to multiply that by 1 yard for every 3 feet, because I need my feet to cancel here. Then I'm going to multiply that by 1 mile for every 17,660 yards. Okay, so I needed yards to cancel, so I put that in the denominator there. So I'm chaining them together, and all I have to do to find the answer, which is going to be in miles, is to do 45,789 times, or divide by 12, then divide that by 3, then divide that by 1760. And when we do that, we get about 0.72 miles. Okay, so it's almost a quarter mile. Part number 8. Here we're going to use our conversions with units raised to powers. Okay, so we need to find a conversion factor that between square yards and square feet. Okay, so I want square yards, and I want to set the equal to some number of feet squared. How many are there? How many feet squared are in yards squared? So numerically, I can go ahead and take my yards squared and set that equal to 1 yard quantity squared, okay, which is the same as 1 yard times 1 yard, which is the same as 3 feet times 3 feet, which is equal to 9 feet squared. Okay, so there's my conversion factor. And here is a little picture of it that we can draw. This is my square yard. So this distance right here is 1 yard. This distance right here is 1 yard. I can divide each of these distances of yards into feet. So from here to here, beginning to end, I'm going to divide it up into 3 feet. Okay, all of those distances are 3 feet. Same thing with this distance on this dimension right here. I'm going to divide this up into 3 feet. Okay, so there's 1 foot here. There's 1 foot here. And there's 1 foot here. Okay, so there's 3 feet by 3 feet. Now across my square, when I'm looking at how many square feet are in a square yard, I bring my divisions out to both dimensions, and notice that there are 9 here, 9 feet squared in this one. So we have 1 yard squared equal to 9 feet squared. Part B, that's part A. Part B has us find the conversion factor between cubic yards and cubic feet. So 1 yard cubed is equal to how many feet cubed? Okay, so the conversion factors for square units and cubic units are different than what you would think. Okay, because there's only 3 feet in 1 yard. Now yard squared, I've put in more yards, and we have more feet squared. Same thing with the cubic units. So we have 1 yard cubed, so 1 yard cubed is the same as 1 yard quantity cubed, which is the same as 1 yard times 1 yard times 1 yard. Okay, and that's the same thing as 3 feet times 3 feet times 3 feet, which will equal to 27 feet cubed. Okay, so 1 yard cubed is equal to 27 feet cubed. And here's a picture of that. Okay, so I start out with my cubic yard. So this distance right here is 1 yard. This distance right here is 1 yard. And this distance right here is 1 yard. Okay, and when I divide each of my distances into feet, okay, so here's the distance here from here to here, divide into 3 parts. Okay, so this right here is 1 foot. This one right here is 1 foot. Oops. And this distance right here is 1 foot. And take this distance, which is our width, and we're going to divide it into feet as well. 1 foot here, 1 foot here, 1 foot here. My height will also be divided into feet, 3 feet, because I'm changing my yards to feet because my overall goal again is to find out how many feet cubed there are. Okay, that's 1 foot, 1 foot, 1 foot. All right, so we have all of our distances divided into feet. So let's go ahead and extend our lines to each of these. Okay, so I'm going to make that a little bit bolder here so you can see that. Okay, and divide each of those into 3 parts. And these ones also into 3 parts. Those ones too, and those ones too. Okay, so how many, here's 1 cubic foot right here, set in with all the other cubic feet in the cubic yard. Okay, so how many of these cubes are there? Well, we know from our number calculation that there's 27, but this is a geometric calculation. Okay, and so we can see visually how much it is. Okay, moving on to 8C. We have a yard example, 8C. Now in 8C we have an area of a yard, a rectangular yard, but that's also measured in yards. So these are different yards that we're talking about. And now I'm going to draw a picture of that to show you how to solve it. So find the area in square feet of a rectangular yard that measures 20 yards by 12 yards. Okay, so this is 12 yards. That's 20 yards. Okay, so we want to find the area of this. So the area is length times width. We're going to set that equal to 20 yards times 12 yards. And 20 times 12 is going to be 240. And yards times yards is yards squared. Okay, so that's the area in yards squared. We want to convert to feet squared. Okay, and so we're going to take our 240 yards squared, multiply it by a conversion factor, which has feet squared up in the top. Well, I'm forgetting what the conversion factor is, but I do know that 1 foot, 3 feet is equal to a yard, right? So we can do 3 feet for 1 yard. And since I want canceling 1 yard here, I have 2 yards to cancel there, so I need to put on another conversion factor so you can chain these together. Another conversion factor of 3 feet for 1 yard because I need 2 yards in the denominator to cancel with 2 yards in the numerator. Okay, and when we've set that equal to something, we're going to do 240 times 3 times 3, and then my units that are left are these feet right here, of feet times feet. And when we do that, we get 2,000, on my calculator I put 2,160 yards feet squared. since I'm changing from yards to feet squared. In part D, I'm going to do a sidewalk example where a new sidewalk is 4 feet wide, 100 feet long, and filled to the depth with 6 inches of concrete. So how many cubic yards of concrete are needed? And when we buy concrete, they sell it in cubic yards, and they just shorten that in their lingo to yards, but they mean cubic yards. Okay, so a good idea to just draw a picture of this. So I'm going to draw this really skinny sidewalk that's really long. So there's the depth of the sidewalk and the length, and I'm going to draw the width now. Okay, so there's our sidewalk, and we have that it's 150 feet long. We have that it's 4 feet wide, and we have that the depth is 6 inches, and I'm going to convert that to feet by doing half a foot, 0.5 feet. And we're going to find the volume of this thing, so it's 150 feet times 4 feet times 0.5 feet. When I multiply all the numbers together, we get 300. And when I multiply all the feet together, we get feet cubed. Now I need to convert these feet cubed into yards. And so we're going to do 300 feet cubed times some number of yards cubed. So we want the feet to cancel, so we put, oh gosh, I forgot again how many cubic feet are in a cubic yard. Well, it turns out that I can just do it again like the other problem, where I do the whatever feet I need for every yard. So I know that there's going to be 3 feet in 1 yard. Okay, and I need 3 sets of feet to cancel with those feet. So I'm going to write this string together 3 conversion factors of 1 yard for every 3 feet. Okay, so these 3 fit on here, these 3 sets of feet will cancel with those 3 sets of feet. And what I have in the end is I have 300 divided by 3 times 3 times 3, and I have yards cubed. And those yards cubed come from here and here and here. What we have for our numbers is 300 divided by 27 yards cubed. And when I do that, 300 divided by 27 is about 11.11 repeating, so it goes on forever. We'll stop with that one and copy down our yards cubed. Okay, so number 9, we have currency conversions. Another type of quantity is money. Okay, so we want to note that the British pound is one British pound is the same as $1.24. Okay, so 1 pound, this is British money, not weight, it's the same as $1.24. We also want to note that there's 1 euro is equal to $1.08. Okay, so both of them are worth a little bit more than the dollar right now. So you want to buy a leather jacket that is 299 pounds in London. How much is this in US dollars? Okay, so essentially we're going to convert 299 pounds to dollars. And in order to do that, we are going to use a conversion factor. So we need to multiply by the conversion factor. We have this one right here. 1 pound is $1.24. And so we need to cancel the pounds. So we need pounds on the bottom and then the money on top for dollars. Where do you want to convert to? So the pounds will cancel. And in order to convert to dollars, I just take the 299, multiply by the 124. And when I do that, I get, my calculator, I get $370.76. Okay, nice expensive jacket. Hopefully it's worth it. Let's see, we have our gasoline example now. So gasoline, let's number these. Okay, our gasoline example is that gasoline sells for $1 for 1.31 euros per liter in Paris. So that's as of the end of last month. And what is the price of the US dollars per gallon? Okay, so we're going to use our conversion factors. And the great thing about it is that I need to convert both units, but we can do it at the same time by chaining up the conversion factors. And so we're starting out with 1.31 euros for 1 liter of gas. And we're going to multiply that by, well, let's convert to dollars first. So we can convert our dollars. You can do either 1.08 dollars for every 1 euro. So I cancel the euros, and I don't have to actually calculate the answer right now, so we can remember because we can chain them together. So we got dollars per euro for units right now, dollars per liter, that is. We need to change our liters into gallons, and we're given that 1 gallon is 3.785 liters. Okay, so since liters is in the denominator, we need it in the numerator. So we'll write our conversion factor this way, so liters can cancel. Okay, now our units left are dollars and gallons, and so that's exactly what we want. So we're going to multiply 1.31 times 1.08 times 3.785, and we'll get $5 when we use our calculator and 36 cents. Okay, per gallon. Okay, so that's our unit. So $5 a gallon. You're grateful that you live in the United States, right? Part number 5. No, actually part number 10. Number 10, we just have one more practice problem to do to help us prepare for our homework. It's a skydiver example. Competition speed skydivers have reached record speeds of 614 miles per hour. At this speed, how many feet would you fall every second? Okay. So we need 614 miles per hour. We need to equal some number of feet per second. Okay, so that's what we're looking for here. So we'll start with 614 miles for 1 hour. Oops. And we're going to use some conversion factors to get us to feet per second, so we can convert either one. So let's start with changing our feet to miles, or miles to feet. Okay, so we want miles to cancel, so we have 1 mile on the bottom, the denominator, so they'll cancel with that one. And there's 5,280 feet in a mile. And then we're going to multiply that again. We got our feet, but we needed in the denominator we need seconds because right now there's hours. Okay, so we're going to multiply by 1 hour for every 60 minutes. Then we'll convert the minutes to seconds, so we'll cancel our hours here. And now we have feet per minute. So we need to multiply by another conversion factor. We need our minutes to cancel, so we'll put minutes on the top, 1 minute for every 60 seconds. Okay, so now we have our feet per second. And all we have to do is multiply the numerators and denominators of all these conversion factors. So we have 614 times 5,280 divided by 60 times 60. And I have my units left of feet per second. When I do all the number work, I get, in my calculator, I get 900.53 feet for every second. Okay, and so that's our lesson for today. I hope that you enjoy the homework, and please let me know if you have any questions. And thank you very much.